Excellent. Thank you very much. Good morning, Berlin. Thank you. One more time. Good morning, Berlin. It's very good to be here and to actually talk to you about the next industrial revolution and to share with you our vision of where that's going. And it's a very relevant topic today, especially here in Europe, as we start driving towards Industry 4.0 and talking about transforming manufacturing and where it will go. And these steps are actually the first steps in what we see is a 30-year vision around the next industrial revolution. So to fully understand what I mean by that, what you have to do is kind of back up, and you have to take a look at what's going on in society today. Not just the technology trends, yes, those are obvious, and we track those closely. But more importantly, what you need to do is take a look at the things that are happening in society. And there's three big things that will have a massive impact on manufacturing. The first is massive urbanization. If you take a look at the trends for the next 30 years, soon we'll have about 8 billion people on the planet. By 2025, 5 billion of those people will actually be in Asia. And almost half of those will be in two countries, in India and in China. And you will have, if you rewind a little bit, in 1990, we had 10 megacities. A megacity is defined as having 10 million people or more. Here in the next 10 years, we will have 41 megacities. And over half of those will be in Asia. Many of them you've never heard of. So this urbanization is going to put incredible demands on how we manufacture, how we distribute, how we actually service those communities, because we're going to have to be much more conscious about things like our packaging, about how we get material in, how we get material out. The second big trend is around hyperglobalization, or what I sometimes like to call glocalization, which is global yet still remaining local. And it's the simple idea that an idea, a concept, or even products can very rapidly be distributed around the world, but at the same time be customized for individual markets. Now those individual markets are changing. Today we tend to market to countries, and we look at the requirements of those countries or the regulations of those countries, and we change according to those. But with the rise of megacities, that marketing will go at the level of cities. And the customs of those cities will become dictating the specifics of those products. Finally, combining these with the massive changes going on from a technology standpoint, where in 10 years, we can have 1,000 times the compute power for the same cost. In 20 years, we can have 1,000,000 times the compute power. And in 30 years, 1 billion times the compute power that we have today. This rapid change in technology and the ability to do things in unique ways, combined with some of these socioeconomic changes, are going to have a profound effect on how our manufacturing is done. To take advantage of this trend that we see, at HP we've developed a simple vision, and we call it blended reality. Now this vision is simple in nature. It's merely taking the fusing together of our physical world and our digital world. So it's taking the people, places, and things and connecting them up in a seamless way to our digital services so we can compute, analyze, and communicate. And these will become much more seamless behind the scenes that happen in ways that, just like electricity 100 years ago, was very novel, and today it disappears into the background. We see this in all parts of our lives today. We see it in medical, where we measure aspects of things on the body, we turn it into digital representations, we compute it, we turn back around and we act. We see it in agriculture, where we measure characteristics of a field real time. We use that to compute what is needed for phosphates or other nutrients. We apply them back instantly. It is that virtuous cycle of from physical to digital and back to the physical. Now we're doing this across several different areas at HP, in mobility, in immersive computing, in Internet of Things, in smart machines. But the biggest area that we're applying it is in the area of 3D transformation, or the next industrial revolution. So to get an idea of what we mean by this, let's take a look at what manufacturing has been for the last 150 years. Rewound and you looked at the history of manufacturing, it has essentially been the same for 150 years. We stage in raw materials, we figure out the best, most optimal way to put them up to a manufacturing line, and then we manufacture them either through low-cost labor or through automated lines, and then we figure out how to stage them on the back end in warehouses and distribution centers at retail stores. And if you can optimize that chain front to back with some very good marketing and positioning on it, you essentially have a competitive manufacturing business. And it didn't matter whether it was Twinkies, tablets, Toyotas, it was essentially the same process. We believe this will be fundamentally transformed over the next 20 or 30 years. And you will see a scenario where we will drive to on-demand manufacturing. And that really gets to the second stage, is how do you transform this so you can go serve the needs of a changing world with denser populations, much more sensitive and much more demanding of the products that they have. And there's two fundamental ways, two fundamental things you have to do to make this happen. One, you've got to simplify the upfront design process. You've got to democratize design so that the design of products shows up in the hands of you, the people who use them. Today, we see that in terms of the maker movement, but as we go forward, we're going to see more and more of this where we can actually customize and change, design the product that we want. The second half of this is being able to do on-demand production. So not only can we take our design, edit it, change it, personalize it, colorize it, but then we can turn around and print it out. So that manufacturing moves from a world in which we staged raw materials into one where we print it on demand in the locale where we see the opportunity or where the goods can be sold. In all, this represents a $13 trillion opportunity, is transforming manufacturing. So let's take a quick look at the front end, and then I'm going to spend the bulk of my time on the back end. On the front end, we introduced a product about a year ago called Sprout. And what Sprout was targeted at was the maker community. And it put in the hands a tool that allowed you to much more naturally work with a computer, and for you to do upfront design and making with your hands and with simple gestures. And going forward, we'll move that product into full-blown manufacturing with a commercial offering that will come next year. But to get an idea of what Sprout is and what it's capable of, let's take a look.
My job can be really stressful. In what little spare time that I have, I like to play music. When I'm playing, everything else melts away. It has a very calming effect. Talking to these kids and having conversations, trying to connect with them, I like to kind of put them in that spot as well, to just let them know that they're going to be all right. A lot of times I just try to find things that I have in common with them. Hey, did you see the latest superhero movie? What'd you think about that? Things that you like to do for fun. Keep them happy and focused on that as opposed to what they're coming into the office for. First thing I discovered on Sprout was a 3D camera. And I was like, this is just so cool. I really wanted to see what I could do with it. I loved watching the computer work, taking the 3D scan of the object. I'd never seen anything like that. The Intel RealSense technology let me capture a 3D scan that you can move around and resize easily. Right now, I'm designing a prototype that could go right on top of a child's cast.
Okay, check this out. You're gonna love this. You're gonna be a total superhero.
I thought this was a really cool idea because I wanted to make it customizable for him. I think making an idea into something real can help the child forget about their fears. That's a pretty great feeling.
So I'd encourage you out in the hall, you can take a look, you can actually play with Sprout out there. And this is the first footprint kind of the footprint in the sand of where we will take the front end to do much more natural design and to put it in the hands of the makers themselves. On the back end, the key is 3D printing. Now today, there's clearly a lot of fascination with it, but it certainly has limitations. There are two main technologies used today. One of them is called FDM, which is essentially extruded plastic, and it allows you, it's basically a glue gun on an XY table that traces out a pattern in a very serial fashion, finishes out a layer, and goes to the next layer. The other main technology is called SLS, which is sintered laser. It essentially spreads a layer of powder out and uses a laser to trace it. But both of them use a serial process, and both of them have four fundamental problems. One, incredibly slow. It can take you many hours to print out a part. Two, very low quality in terms of they can only do a single material, one set of properties, and in the case of FDM, limited in the quality itself. Very expensive, and they're closed platforms. So what we're doing at HP is we have created a technology, multi-jet fusion, that will radically change this. And it addresses all four of them. One, it will print at a minimum of 10 times the speed, and in many instances, up to 100 times the speed of current technology. Two, it'll do it at much higher quality. I'll talk about that here in just a second. Three, it'll do it at 20% of the cost. And fourth, perhaps most importantly, it will do it with an open platform. So to understand this, the best way is take a look at the quality of what we're able to do with multi-jet fusion. In multi-jet fusion, instead of operating with a single bit with one single property, what we have the ability to do is control manufacturing, control printing at the voxel level. A voxel, very simply, is like a pixel in 3D space. And that means every single 3D point, the properties can change. So we can do things like change the color itself. Through these agents, we can make it a particular color. We can change it, and we can make it different surface properties, so it's smooth or it's rough. We can change translucency, so it can be solid or it could be transparent. We can change elasticity and strength, and we can do it throughout the part. And we can change the electrical conductivity. We can print electronics. And finally, we can do it with advanced materials. So we can do it with thermoplastics today, moving to polymers, and moving ultimately to metals and ceramics. And all of them being able to combine in complete subsystems. We have the chance to do things that are very radically different than today. So we can do things like print a part that has all variants of color in it. Or we can print unique structures that can be a lattice structure, but we can change, remember, the physical properties. So it actually is rubber, like an elastomer ball. These sorts of technologies will be fundamental in how we actually change manufacturing. The other main thing we're doing, which is very unique, is we will create an open platform. So this will not be a closed proprietary product that only HP will offer. We will have published interfaces through APIs. We'll have an SDK that people can actually write to the platform, and we will actually open up the materials for innovation so that other people can bring different types of materials onto the platform for their particular market, making it truly an open platform for manufacturing. So what this will allow us to do, when you combine all of these together, is completely reinvent manufacturing. Now, it may take, 30 years to see this transformation, but it will happen. And we will watch it in pieces. Next year, we will roll out the first multi-jet fusion product, and we will follow it with subsequent generations already on the roadmap, and we're going to watch transformations in workflow, in manufacturing, and in deployment. Now, we see some of these happening today, actually, if you take a look at the industries around us. One, if you look at airlines, if you flew in here like I did, I could almost guarantee you that the airplane you flew on had several components that were 3D printed. In fact, much of the jet engines and the nozzles themselves are actually 3D printed. And in the case of automotive, obviously a big concern here, they are rapidly adjusting to 3D printing as a component. Imagine a world in the not too distant future where instead of having to stock the parts and have them in warehouse when you need to do a repair, you actually find out what part you need, you pull down a digital representation in the locale where you are, and you print it out on demand. It will fundamentally and radically change manufacturing and many aspects of our society today. But we're not going to stop there. I'll give you just a little tease of some of the work we're doing in HP Labs that will point at the future, and that will be 4D printing. In 4D printing, you have smart materials where you actually print them out, and then they have active properties that can change over a period of time. So imagine the table that you purchase at IKEA, and today you bring it home, you hope you had all the screws, you assemble it together and hope you weren't too frustrated about it. But imagine a world in which you go to IKEA, you purchase it in the box, you open it up, and it self-assembles. That is what 4D printing is about, is self-assembly. The ability to program in particular areas of the material and be able to activate it through heat, water, chemical reaction, pressure, many other sorts of external influences to actually do self-assembly. Altogether, these represent what we believe will be the next industrial revolution and a fundamental transformation in manufacturing overall. And one last thing, very good discussion this morning. I've loved the intensity and the ideas that have come out. But in the next industrial revolution, Germany will have a very large role in it. Several of the companies today who are leading in 3D are actually based here in Germany. Startups who are working on the workflow associated with this that will lead to the next industrial revolution are based here in Germany. In fact, tomorrow I will be with a roundtable of them who are looking at whole new ways in which to transform the workflow in this next industrial revolution. So if you'd like to learn more about that, please do follow me. You can get me on Twitter at Shane Wall CTO, and you can follow our latest trends. You'll see our announcements. You'll see other fundamental changes that we intend to do in 3D and in the next industrial revolution. So with that, thank you very much.
At this point, we'd like to take some questions for Shane from the audience, and we have 3 microphones set up. There's one here to my right, one to the left, and one in the back in the middle. So if you have a question for Shane, please make your way to the microphone so he can hear what you have to say. A packed house and no questions? Okay, I'll start things off.
Yeah.
You guys break the ice. How long is it going to be, time-wise, until I, as a consumer, can look forward to having 3D printing technology in my home?
Well, today, you can do it today, right? I mean, you can buy low-cost 3D printers today. The problem is the quality. So what you ultimately want is you want the ability to do a very high-quality part the way you want it today. And that will happen in the very near term through distributed services. You will design and define the product, and then you will hit print. It will send it to a standard shop. It will print it out and mail it to you. That you see a little bit today. You'll watch that over the next 2 to 3 years. Before you have it actually of that quality in the home, you're probably looking at the 5 to 7 year time frame before you'd have quality that you'd go, okay, that is equal to what I can buy online.
It's still pretty good. All considered, 5 years to print my own 3D models. That's pretty cool.
Yeah.
Any questions from the audience for Shane?
Easy audience.
Oh, right here in the front, please.
Yeah, actually, how does this printing with the advanced materials like metal work? Is it kind of a simpler material, or what's the
Yeah.
basic stuff?
Yeah, so to repeat the question is how do some of these advanced materials like metals work? So in the case of metals, it's, there are a few different techniques, but the primary technique is you start with a bed of metallized powder. And you spread a very thin layer of that powder out, and then you come along today with what's called sintered laser, and you use a laser, and you shine a very bright spot on that piece of metal, and it basically melds it back together in that one location. You trace an entire pattern, you lay another set of material out and do it again, and you just repeat, and it builds up. Now, as we go forward into multi-jet fusion, we'll use a similar bed of powder, but we will actually use transforming agents where it can be at every bit, you can have a different property. And that's what becomes truly unique in the multi-jet fusion case.
And I think we have someone here at the microphone. Please go ahead, sir.
The mic is on? Yes, now. Shane, you talked about the multi-jet fusion devices rolling out next year, and these devices that will be out first, will they be intended for industrial customers, small businesses? Who is the target for these devices?
Yeah, so our first products will go after more on the industrial side, so it'll be for prototyping and low-volume manufacturing. That is where most of the market is today. In fact, if you look at the 3D market today, 95%, probably more, is actually sitting in that area. So that is where it will start. That's why, my answer earlier, it will be a while before you watch it move to the consumer side, but it will start certainly in that industrial.
Quick follow-up.
When do you think that the price of these devices will be able to, for small businesses to build something maybe comparable to what was copy shops 10 or 20 years ago?
Mm-hmm. Yeah, so I think you're looking in probably the 7 to 10 year time frame, maybe a little bit sooner. Knowing the roadmap is you're going to have what we call work group printers, and these are going to be below $10,000, but have the quality of machines today that are around $1 million. Yeah.
All right, and we'll take one final question from this gentleman.
Thank you. I'm actually fascinated by your idea of 4D printing. So can you say a little more about this? I presume that's time as the fourth dimension. And what will be the forces that will be used to do the self-assembly you're alluding to?
Yeah, so in 4D printing, actually the fourth dimension, or the four in it, is self-assembly. Okay, so it's the whole idea that I can print a part out in a single place, but at the properties at a junction, I have different material properties at the boundary. And by the addition of heat, water, introduction with air, chemical reaction, and the like, you change the properties at that boundary. They're called active materials. So you can have where something meets and it'll actually fold. And then you end up with, and there's some interesting stuff if you want to see what's publicly out there in research institutions. They have some of this going on at universities today.